In today's lesson, we are going to be looking at factoring what we call simple trinomials. So what we want to do first, we're going to do a little bit of a warm-up. Using algebra tiles, you can have these in person, or you can find virtual versions of this. I want you to create a rectangle with the dimensions shown in the table. Right? So the table is going to show your different lengths and widths, and I want you to come up with the area for that table, or for that rectangle, sorry, and then determine what the value of a and b is for that area. Right? So the area you're going to have in some form of x squared plus bx plus c, and you're going to have then figure out what the value of b and c are. Right? So this is kind of similar to what we were doing before when we were expanding using the algebra tiles in a previous lesson. Here we're just going to consider the answer or the product of this expansion as the area. So if I have x plus 3 and x plus 4, I should end up with x squared plus 7x plus 12. For the next one, I'll have x squared plus 8x plus 15, x squared plus 9x plus 18, x squared plus 8x plus 16, and x squared plus 9x plus 20. Now, if we go through and find the value of b and c, b being the value that is attached to the x, so in this case, for the first one, it'd be 7, and then 12 for c, the constant at the end. I'm going to go through 8 and 15, 9 and 18, 8 and 16, 9 and 20. So again, you can go through and do those, use the algebra tiles to make those rectangles, and these are the answers that you should be getting. So what do you notice about b and c in the binomial factors, or the length and the width of each trinomial? So essentially, for example, the first one, we are looking at these two values and these two dimensions. So is there a pattern between what the length and width are and what the value of b and c are? And you can look at all the other examples as well to see if that pattern continues for other binomials. And what we should notice is that the value of b is the two values in my factors added together. Right? So if I look at 3 and 4, 3 and 4 add to 7. Right? I can kind of use that idea for c. The value of c is the two values in the factors multiplied. So what we're seeing here is that the two values that are in the factors are being added to get the middle value of our trinomial and being multiplied to get the last value. And that is what we're going to use to help us factor these types of trinomials. So when we multiply two binomials together, the result should be a trinomial, and we're going to use that idea to help us factor. So if we're given a simple trinomial, which would be in the form x squared plus bx plus c, there is a rule to factor it. And what we're going to do is we're going to find, we're going to find two values. We'll call it r and s, that multiply to c and add to b. So once we find those two values, we're going to plug them in. So we're going to plug r and s into two sets of brackets with x, or we'll call it just our variable because it might be a different expression that has a different letter. So with x, or the variable, as the first term. So what that means is that if we're factoring, x squared plus bx plus c is going to become x plus r and x plus s. And r and s we're getting because r plus s, or say r times s first, r times s, let me color code this. R times s will equal c, and r plus s will equal b. And whatever r and s are, they go into our brackets with x, or the variable, as the first term. Right, now, one thing to note, not all quadratic expressions in this form can be factored. Right, so there may be scenarios where we can't find two values that multiply to c and add to b. Right, so that might be a case where it just can't be factored. And now keep in mind, when we're looking for these factors, we're looking for nice numbers. Right, we're not looking for decimals or anything, or fractions or anything like that. We're looking for nice whole numbers. So this is where knowing our times tables becomes really helpful, because it allows us to think of all these different numbers that can multiply to what we're looking for. So let's look at an example. So x squared plus 7x plus 12. Right, I'm just going to write at the top our general format for a simple trinomial, x squared plus bx plus c. And the reason we do that is because we're going to need to look for what our b and c value are. So in our equation here, x squared plus 7x plus 12, our b value is 7, our c value is 12. This means we're looking for two numbers that add to 7, and those same two numbers multiply to 12. Now, I would say start with the multiplication first. And the reason I say that is because there are less numbers that multiply to a value than there are that add. So I'm going to start looking for the two numbers that multiply to 12, right? And again, if you don't know, you can go through all the different factors. 1 and 12, 2 and 6, 3 and 4, and I believe that's it. And with those numbers, we're going to see, okay, are there any of them that add to 12? Or sorry, add to 7? Right? Well, 1 plus 12 does not equal 7. 2 plus 6 does not equal 7. 3 plus 4 does equal 7. So that means 3 and 4 are going to be my two values that satisfy, or that fit this rule or these steps. So because 3 and 4 are my two values, they're just going to go into brackets with x plus 3, x plus 4, with x, because x is our variable, and that is our factored form. Now, order doesn't really matter, so you could put the 4 in the first bracket and the 3 in the second. Doesn't really matter because we're multiplying. But that is how you factor simple trinomials. Let's look at the next one. 2x squared plus 6x plus 10. Right? So looking at this one, this is not a simple trinomial. And the reason it's not a simple trinomial is because of this x squared, or this 2 in front of the x squared. A simple trinomial would not have anything there. But there is something that we can do to help us get it to a simple trinomial. And what we're going to want to do is we're going to want to common factor first. So if I common factor, I'm looking for a coefficient or a value and a variable, value and or a variable that go into each term. I'm going to look at the coefficients first, and I can see that I can take a 2 out of every term, or 2 can be divided into every term. 2 is my greatest common factor. I can't take an x out of, or have an x in my greatest common factor because this last term does not have a x on it. So I can only take out a 2, and I'm left with x squared plus 3x plus 5. Now, this trinomial in the bracket is a simple trinomial. So now I can go through the steps similar to what we did above with just the trinomial in the bracket. So the b value is 3, the c value is 5. Right? So we're using the common factored one. So two numbers that multiply to 5, and the same two numbers add to 3. So the only numbers that multiply to 5 are 1 and 5. The numbers, there's no other numbers, and 1 plus 5 does not, 1 plus 5, does not equal 3. So what this means then is that we can't factor. There are no numbers that multiply to 5 and add to 3. We can't factor any further. So in this case, the only thing that we could do was common factor, which is fine, right? It's fine to just be able to common factor. We just don't want to be discouraged and say, oh, like I have to find numbers. No, that's okay. This is as far as we can go in terms of factoring. So we can't factor further. No two values multiply to 5 and add to 3. Right? You don't have to state that. I'm just putting that down so we kind of know why we can't factor any further. Right? If the question was just to factor, you would just leave it as we just did. You common factored, and that's it. If I look at C, right, so this is a simple trinomial. The value in front of the x squared is 1, or I don't see a value there. So the values, or the b value is -7. We do want to make sure we include the sign in front. We want to include the sign in front when we find our values. So -7 for b and 10 for c. So two numbers that multiply to 10 and add to -7. Because they multiply to a positive value, right? But they add to a negative. This means that my two values that multiply have to be a negative value, or both negatives. That's the only way I can multiply to a positive and add to a negative. So I can go through all the factors, 1 and 10, 2 and 5, and that's it. Make both of them negative, and I can go through and check. So -1 plus -10 does not equal -7, but -2 plus -5 does equal -7. So that means my two values that I'm going to use in my factored form are -2 and -5. So in my two brackets, I'm going to start with x because that is the variable that I have. One will be -2. The other one will be -5. Again, it doesn't matter the order. We're just plugging those two values into our brackets with x. We're keeping the signs that we found. So because they were -2 and -5, it's going to be -2 and -5. Last example, x plus 4 times x, or x squared plus 4x minus 5. B value is 4, C value is -5. So because it's two values that multiply to a negative number and that they add to a positive, in order to multiply to a negative, one of those numbers has to be negative. Now, because they add to a positive also, the larger number of my two factors, or my two values, should be the positive one. Right? So that's just kind of a trick that you can use to kind of help figure out what signs your values are. So if I go through for -5, I have 1 and 5. Now, because it multiplies to a negative, I have to think about which one do I want to be negative when I check, right? When I check the addition part. Because it adds to a positive, my larger number should be positive. My smaller number should be negative. So -1 times +5 is -5. -1 plus 5 is also 4. So that works. That fits that pattern. So the two values, or my two brackets, are going to be x first in both of them. One will be +4, and one will be -1. Oh, sorry, not +4, +5. One will be +5, and one will be -1. So we're just finding two values that multiply to our C value or the last value and add to the middle. Right? It has to be the same two values that multiply to the one and add to the other, right? We're not having different sets of numbers. Once we have those two values, we put them in brackets with our variable, making sure to keep the sign that they are. So this will take some practice, right? Knowing your times tables is really helpful because it will help you find what your two possible values could be. Right? If you have access to a times table or something like that, that will also be very helpful. Right? Because this is a new concept, please make sure you are practicing, right? The more you practice this, the more you get comfortable with finding these numbers, plugging them into the brackets, making sure they work, right? So the more you practice it, the more you'll feel comfortable with these types of questions. Right? So again, at this point in the unit, we should be able to, or we want to check, can we expand a binomial? Can we common factor expressions? And now can we factor a simple trinomial? Right, so there's going to be some practice with that. Right, go back to the previous lessons if you're not quite sure on some of these knowledge check concepts. Right, review those previous lessons because it does help, and they do factor into these different or to these future concepts.